Alright guys, welcome back to our first video after spring break. You guys, we are on page 517 for the notes, so if you want to go there and take notes, that would be awesome. And we started looking at similar polygons and how we find the corresponding parts of the similar polygons, how we can tell if two triangles are going to be similar, if two of the angles are congruent. Now we're going to look at polygons and scale factor. So on page 517 you can kind of follow along. Scale factor is the ratio of the lengths of two corresponding sides of two similar polygons. Since corresponding sides are proportional, we can use the scale factor to find missing measures. So for instance, AB corresponds to XY. The scale factor is 1 to 2, so 3 over 6 simplifies to 1/2. 2 over 4 simplifies to 1/2. 2.5 over 5 simplifies to 1/2. So the scale factor is just taking a side from one and dividing it by the corresponding side of the other. And we talked about this in a previous section, that if they are similar, all those ratios will be exactly the same. So let's look at an example of this. And this is still on page 517. These two quadrilaterals are similar. I have 3 sides of this one and 2 sides of this one. I want to find the missing side, which is this one right here. So these are drawn in the same orientation. So this side corresponds to this side to this side, this side to this side. So the missing side, M, corresponds to this side, 12. So the first thing we're going to have to do is find the scale factor. And we'll look at 2 methods for doing this. One way to do this is to find the scale factor from the smaller to the larger. So, or this says from this to this, but it really doesn't matter like which order you put these in, as long as you keep it consistent. So the ratio of corresponding sides, these are the only 2 sides where we know on both of the quadrilaterals. So we could say that the ratio, since we are already given that they're similar, then we know that the ratios of all the sides will be equal. So we can just use this side and this side that we know, which is 15 to 10, or this simplifies to, if we divide each of these, you want to divide them and simplify them as much as possible. We could divide each of those by 5 to get 3 over 2 for this one. So now that we know the scale factor, what we're going to do is use that to find this missing side here. So the missing side, M, is going to be 3/2 times 12. So like 15 is 3/2 times 10, because 15 over 10 is 3/2. So 3/2 times 12 gives us 18. So the missing side is 18 units there. Now, another way you can do this is to use a proportion. And I kind of like this method better. You can use whichever one you want. But if we want to use a proportion, I think it's a little simpler to do this. But again, you could choose whichever method you want. We could say that the missing side over the corresponding side of this triangle is equal to 15 over 10. So we have one side, if you look, both these numbers on the top come from this quadrilateral, not triangle, I think it's a triangle, and both of these bottom numbers come from this one. So the corresponding side of this quadrilateral to 12 equals the corresponding side of this to this. Okay? Then, to solve a proportion, we do what's called cross multiplying. We would, well, they do it a little bit of a different way. So the way the book does it, they're figuring out what we need to multiply by. So again, one way to solve this, I think it's a little more confusing to do it that way. One way to solve this is to cross multiply. So we would have 10m equals 15 times 12, which is 180. So you can solve a proportion by doing this, multiplying diagonally. And then this is a simpler equation to solve. Divide both sides by 10, and you get that m equals 18. So that's how you would solve this using a proportion. Let's look at another example of that. This is not in your book. You can write this one in the margins if you want to have an extra example, but I'm going to do this one using proportions. So we want to find the missing side measures, which are x and y, and just be careful here to figure out which sides are corresponding. So let's see what we know. I think if you look, this has the 3 markings and this has the 1. So this is the 3 and the 1. So that means this side and this side are corresponding to each other. So the ratio, I'm going to start with the smaller triangle. That side I know, over the side I know of the other triangle. And I'm just going to find one of these sides. So I'm going to find GH. And GH is the bigger triangle, so that should go on bottom here. So what side does this correspond to? Well, that corresponds to, here's the 2 and the 3, and here's the 2 and the 3. So this side corresponds to this side here. So x corresponds to 6. Now, since the 3 comes from the smaller triangle and is on top here, and the 6 comes from the smaller triangle, that's why this is on top here. And then this 6 is the bigger triangle, and this x is the bigger triangle. So notice that the sides of the same triangle are in the same position, on the top or the bottom. And then to solve this, we cross multiply. We would say that 3 times x is 3x equals 6 times 6, which is 36. So my missing side length then, if I divide by 3, is 12 units. And we will look at some more of these tomorrow, but see if you could try the check problem on the bottom of page 518. Okay, and if you have any questions, write down what your questions are. And if you have no questions, write, I have no questions. And that way, I know that you've watched this, and I know if you have questions or not. So please make sure that's included. I'll be checking this, and this is what you need to get credit for watching this video. All right, have a good evening.